Hi, everyone. We're going to just wait a few more minutes for everybody to get in, and then we'll get started. Welcome, everyone, and thanks for joining us for another Engineer to Engineer Live Forum. Today's topic is Maximize Your Drive Design. I'm Libby Olson, Digital Alchemist for Gates Corporation. Before we get started, I want to point out the Q&A window in the upper right corner of your screen. So please feel free to type your questions as you have them, and Michelle will answer those at the end. With that, I'll turn it over to Michelle.
Thanks, Libby. Today you'll learn how to design and maximize two-point drive solutions in minutes, optimize your drive designs by cost, speed, or center distance, and determine the recommended installation tension to maximize your drive performance. A few things to remember before we get started. DesignFlex Pro is a two-point drive design program designed to work with Gates synchronous and V-belt products. You can download the software later for free at gatesdesigncenter.com. If you're designing a drive containing 3 or more shafts, you can access our Design IQ software, also available on gates.com. Throughout the forum today, we'll have overview slides followed by demos of the software in use. Let's start with the desired belt line dropdown, which allows you to choose from synchronous, V-belt, or roller chain replacement. Please note all the product lines that are in bold are Gates' newer premier products, so you'll know you're choosing the most current technology and products. Let's take a look at a quick example where we select Polychain GT Carbon and Super AC. So if you expand synchronous, you'll see that Polychain's in bold at the top, and you can select all of the Polychain pitches or just the ones that you want. With V-belt, Super HC is also in bold, and here you can pick all of the cross sections or just one. The next thing you're going to enter is your loading information and service factor. So you're going to have an input load, which is going to be either the nameplate loading on your motor, or it can also be the load on the output of a reducer. If your belt drive is on the output of a reducer, you're going to want to put that information in as well. And then you're also going to select a service factor, which is basically a multiplier that helps make sure the drive is adequately designed for the type of application that you have, the type of startup load you have, and how many hours per day it's operating. So we'll take a quick look at a quick example for 25 horsepower, 284 team frame motor with no gearbox and a fan that's running 24/7. So the motor you can actually pick from a drop-down or type in your number. Same with the RPM. It has some standard RPMs loaded, but you can put in other things. You can select the motor frame if it's an electric motor. With no gearbox, you'll put in a service for a ratio of 1. And then for service factor, you can go to help, and then it actually has a chart where you can pick your application, hours per day, and start upload, and it will set the service factor for you. So next up, you'll enter the speed ratio. And speed ratio is always a number greater than 1. It's going to be the large diameter divided by the small diameter. And then we define it as either speed up or speed down based on the driven speed versus driver speed. So we'll take a look at a quick example of a 2-to-1 speed down ratio, or 875 RPM. So you can either type in the RPM or you can type in the speed ratio, and then you can see when you put in the speed ratio, it says the RPM for you. Next up is center distance, which is going to be the distance from the center of the driver shaft to the center of the driven shaft. And you're also going to have a range in there because you need room to both install the drive and for any additional take-up that might be needed. So we'll take a look at a quick example of a 24-inch center distance with a 10% tolerance. And you can see the 10% tolerance is already set there. That's the default. But you can also put in a minimum and a maximum value if you have a specific range you're looking for. Finally, we're going to take a look at some additional parameters that you can put into the program that will help you narrow down the options. So you can pick specific bushing types or materials. You can also go and put in shaft information and the diameter and length. And you can see for this example, since we picked that 284T frame motor, it automatically fills in the shaft diameter and length for you. And we'll put 2.5-inch diameter for the driven. You can see you can do different units in the program. And then once you've put all your information in, you can go hit design. So once you've designed your drive, it's going to bring up all the options that are available to you, and then you can sort through that to find the drive that works for you. So depending on what parameters are important to you, you can use that sorting to find your best drive. And the default is on cost, but we'll take a look at that. So since we designed synchronous and V-belt, it has those on 2 different tabs. You can take a look at all those different drive options. Again, here it's sorting by cost, so the least expensive drive is on top. You can also sort on diameter. You can sort on RPM. You can sort on over design ratio, or also center distance, belt pull, width, or noise. And if you go over to the left side and hover over the little document icons, you can see that there's different notes associated with drives. You might encounter problem drives. If you take a look at those, you'll see why those are not recommended. For example, the top one is not recommended because it does not meet NEMA requirements. So once you've picked a drive that you think is a good option for you, you can double click on it and it will pull up a drive detail report for you. And so we're going to take a look at the drive detail report now. So at the top of that, you're going to have the information that you put in for the initial screen. So it has all the inputs, the horsepower, center distance, everything that you entered into that initial screen. And the next section is the selected drive. So it has the actual speed ratio, horsepower, over design ratio, belt pull, center distance range for the drive that you've selected. And this section also has all of the part numbers and product numbers so that when you do go to order the drive, you know what those are. And lastly is the tension section, and this has the installation tension information. so that when you do install the drive for the first time, you can set the tension to the proper value so that you can have the maximum performance out of your drive.
Great, thanks, Michelle. I just want to remind everyone, we have a couple of great questions already, and I want to remind everyone if you have any questions going forward, please feel free to type those into the Q&A section in the upper right corner. Our first question, Michelle, is if only the bolded sections are required, why would I fill in more information?
So additional information is going to help you narrow down the drive options. So the more information you put in, the more the program will narrow things down for you. So one example is if you know your belt guard limits you to a particular diameter and width, you can add that information and then into the driver and driven pulley section. And then you'll only get drive options that meet those requirements.
Great. Why would I want to minimize the over-design ratio?
So the main reason is going to be because that will help you minimize your overall drive cost. But if you do have a drive that has way too much capacity, it can also increase the static shaft loads and it can reduce your drive performance.
Another question, does NEMA apply to gearboxes?
So no, NEMA diameters only apply to electric motors. However, you do want to check with your gearbox manufacturer. They use something called overhung load. And so you want to take the drive and check with your gearbox manufacturer to make sure that the shaft loading is within the limits that they set.
And what is the difference between belt pull and static belt pull?
So static belt pull occurs when the drive is stopped and is created by the belt installation tension. So it's when the drive isn't running. Belt pull in the selected drive section is the estimated shaft force when the drive is running.
Great, and our final question so far is which product line should I use if I am concerned with energy efficiency?
So in general, synchronous is going to be a great option because it's about 5% more efficient than V-belts. So our two premier lines in that are Polychain and Power Grip, so either of those would be great options.
Great, and that is all the questions we have for today.
Okay, so in conclusion, DesignFlex Pro is a simple yet powerful drive design tool. And now that you have greater understanding of the program and the drive design report content, you'll be able to make more informed drive selections. Ultimately, you'll discover how to maximize your drive design for peak performance, efficiency, and reliability. And I just wanted to share our contact information, so if you do have any questions on using DesignFlex or applications that you're working on, you can contact our application engineering group. And our email is ptpasupport@gates.com, and the phone number is 303-744-5800. Thank you for joining us today.